Alright, hello everyone, this is Mr. Crozier. I'm going to do problem number 6 here from the worksheet. It is find the derivative of 2x squared minus 2x. So here we go, number 6. Well, we know we need to use the difference quotient, which is right here. And so what we're going to do is to find its derivative, and that's the notation for the derivative. We're going to take the limit as h goes to 0 of the function with a x plus h entered into it minus the function there. So this is the first function, same thing with x plus h, minus the same thing with just an x all over h. Now it's just a matter of simplifying it down. Let's see here, we can FOIL this and we'd have x squared plus 2xh plus h squared. Can distribute that. We can distribute the subtraction. Make sure you have right there it's plus 2 at the end. That's all over h. Now we can distribute this in there. So it's just a lot of algebra is what these problems are. And we've gotten to this point, and now what happens always is neatly things go away. So 2x squared minus 2x, and I'm left with 4xh plus h squared minus 2h. And now this is when you want to come down and just go ahead and rewrite this left side, because remember we're taking the limit. Can you plug in 0? Still no, but now we could divide everything by h. They all have an h in them. So if I divide everything by h, I have 4x, I have plus h, and I have minus 2. Now I can plug in h, and if I plug in h here, I simply have 4x minus 2, and there's our derivative. So our derivative is 4x minus 2. That means this function, let's see what this produces if I get my graphing calculator out here. Have my graphing calculator here, and if I type in y equals 2x squared minus 2x. Now if I hit graph, you'll see a graph of the parabola right there. So now what I want to do is figure out, according to the directions, I've done the derivative. Now I have to figure out the tangent line at these points. So my points now are x equals negative 2, and x equals 2, and at x equals 4. So I have those points I have to find out now. I have to find a line that's going to go to those points. Whoops. I have to find a line that's going to go to those points right there. Alright, let's go ahead and set up our lines. All of our lines are y equals mx plus b. Y equals mx plus b. And I know the slope now because I have this derivative. This derivative is f prime of x is equal to 4x minus 2, which is the slope. So the first slope is 4 times negative 2 minus 2. It's negative 10, so it's 4y equals negative 10x plus b. My next slope is 2. 4 times 2 is 8, minus 2 is 6. My next line is 4. 4 times 4 is 16, minus 2 is 14. So I have my slopes. Now all that's left is I need to be able to find my intercepts. Well, that takes a point. So we need a point that's on this line. And the points on all of them are from the initial equation. This is negative 2 input, this is 2 input, this is 4 input. But what do I input them in? Well, I have to go all the way back up here to this original equation, because this original equation is going to give me the output. So easily on a calculator, you could just type in 2 times negative 2 minus 2 times negative 2. Don't think that's showing up very nice. Let me see if I can change the lighting real fast. Maybe that would be a little better. And then I can put that in there. And now I have enter. Oops, let's try this again. Let's try it again. 2, negative 2 squared minus 2, negative 2. Alright, I have an output of 12. And now let's take 2 and plug it into the equation. 2 times 2 squared minus 2 times 2. That's 4. And now let's check this 4. 2 times 4 squared minus 2 times 4. I'm not sure if I did those points right, so I'm going to show you a neat way to check them on here. If we have our equation in here, which we do, we can simply go to table set, have it ask for the independent variables, and let's just go to make our own table. Let me delete these ones here. And we'll just enter negative 2. And it outputs 12. It's the calculator is running it through this formula when you're doing this table feature. So let's plug in 2. 4. Let's plug in 4. 24. Alright, we did get them right. Alright, so now that we have that, it's simply a matter of taking these and plugging them in here. So this is the x and y. 12. Negative 2 here plus b. Let's see, what would that be? That would be, this would be 20 over here, and I'd subtract it over there, so 12 minus 20, negative 8 equals b. And we've found a tangent equation. Let's go ahead and stop right there, because I haven't checked this yet, so I'm not sure this is right. Let me show you a couple neat ways to check this. If you press stat, and then press edit, you can make your own list here. I'm gonna list these points. Negative 2, 2, 4, and 12, 12, 4, 24. And you see what I've done? I've listed these points. I have the point negative 2, 12. I have the point 2, 4. I have the point 4, 24. And I can plot these points now. If I press y equals, and I go up here and I go to plot 1 and I press enter and I highlight it, now the plot's highlighted. When I hit graph, it's going to plot these points for me. And I can see one of them right there. Now, can't see all of them. Let's change the window here. For the x's, I have negative 2 to 4. So I'm going to hit window. And let's just go a little bit to the left of that point and a little bit to the right of that point. And now going up and down, I have 4 and 12 and 24. Let's just start at 0 and go up to 30. And there's my 3 points. And there's my parabola going through them. Alright, let's graph this line. And this line should hopefully, if we've done it right, it'll touch that point over there. Y equals, I haven't done it yet, so maybe we made a mistake. But no, it's right there, that line touches it. Alright, let's go ahead and do this one. Well, I plug in a 4 there. And 6 times 2 plus b. What is that? 12. 4 minus 12 is negative 8. It's b. Y is equal to 6x minus 8. Well, it should touch that point right there. Y equals 6x minus 8 graph. And there it does. It touches that one. I'm going to zoom out just a little bit. Let's go out to negative 6 and 8, and let's go down a little bit further, negative 5, 40. Give us a little bit better view of it. There's a graph, there's a tangent line, there's a tangent line. Alright, we have one tangent line to hit left. Well, let's go about even a little bit further. Sometimes you play with the window here, you get a much better picture of everything that's going on. I think that'll be real nice. Tangent line, and now we need one more tangent line. At this point it needs to be going up. It has a high slope, 14. Alright, 24 goes over here. 14, 4b. What would that be? Make the work real easy on yourself here. it'd be 24 minus 14 times 4. It's a negative 32. So let's see here, 14x minus 32. And hopefully our last one will hit. 14x minus 32. And again, that's what we're trying to do, and there it is. Let me take the other ones off. If you hit y equals, you can go back, and I can close these off right here. See, if you click on them, you can unhighlight them. So now it's only going to graph this one, turn them off, and then turn them back on if you want to see the graph made again. And there's the points, there's the graph, there's the tangent line. It's going right there. Alright, I want to show you one more really super neat thing that you really need to figure out on the calculator. If you go to y equals, let's take this off and hit quit. You can have your calculator calculate these for you. If you're on the graph screen, all you have to do is hit second draw right there, and 5 for tangent line, whoops, graph, second draw, tangent line, and it's going to ask for an input. So let's say -2. Press enter. It draws that line, and it's going to give me that equation. So you can check them off, make sure they're right. So let's do this one. Second tangent, number 5. It's asking for the input of 2. Input of 2. It draws it, and 6x minus 8. And the last one, second draw tangent. Input day 4. Enter, and tangent line, and 14 minus 32. Alright, that's our job. Our job is to find that slope, that tangent line. And how do you know if you get it wrong? Well, we haven't seen any that we've got wrong. Let's see this graph here. A graph that would be wrong would look like this, right? It would be y is equal to, let's just try 2x plus 7. That's a secant line. That line's going through it from point to point, and we're talking, and we want the slope at a single point, not from point to point, the slope at a single point. Alright, I hope that helps. You do have to start at the top, work through this, a lot of algebra. Once you get down to the algebra, you can find a way, use this equation to find the slope, plug in a point, and go from there. And just remember that this equation right here gives you slope. This equation right here is for the points. First equation for the points, second equation, derivative, is the slope. Alright, hope this helps.